Omicron. That virus is not something to play with. Your only protection is, I call it do-it-yourself protection. You protect yourself with that virus. And that means stay out of tightly compressed groups of people. One example is an elevator where they packed 16 people into a little space. That's an ideal transmission place for this terrible virus. In a classroom, you should have an empty seat on each side of you. Every person should have an empty seat on each side of you. That's protecting yourself when the administration won't protect you. So a hint here is compressed groups are transmission zones, and I'm avoiding that compressed groups myself. No one else is watching out for me. You got to watch out for yourself and protect yourself. If you insist, you can come in the classroom and watch me teach to the empty seats and stay 12 feet away from me, and I'll stay 12 feet away from you. Don't sit close to a neighbor in the classroom. The downside is if you start being an in-person student, you don't get open notes during tests. You have to take your test in the classroom, and then I watch you and tell you to put away your notes and put away your computer and don't surf to any websites and do the test by memory. And we all get along. But if you're taking the test remotely, I'm not watching you, and you can do anything you want. You can look at all your notes and all your programs, everything. It's wide open that way. Okay. So those are the rules of the game for us for the rest of the semester. Okay. Everyone's with us?
Sir,
I got to tell you one other bad story, class.
can we get permission to record?
Yeah, when I finish criticizing the administration.
Sure.
Okay. Last year, when past years, I'm using past tense. There was a teacher in the computer science department who I didn't know really well, but I sort of knew him. We greeted each other from time to time, passing in the hall, and said nice things. But apparently he didn't believe in social distancing, and he didn't believe in masks or staying out of classrooms with tightly packed people. And he is now in intensive care in a hospital and is expected to die very soon. He's hanging on, but the doctors there have said, you're terminal. You aren't going to make it. He may be already dead. I haven't heard news since about 3 days ago. It's a roulette that I'm not going to play myself. And I think all of you, I want you to join the technological workforce and be productive out there. I don't want you to be buried early. That's what this COVID is about. 800,000 dead in the United States alone in 18 months. That's it's going to reach 1 million people soon. Okay, let's go on to more pleasant topics. Some of you, these are just announcements. We'll get to real technology in a moment. SI, maybe you're a transfer student and you haven't heard of it. If you're new to Cal State Fullerton, SI is your peers teaching peers, peer-to-peer teaching, and it's going to happen this afternoon. What it is I teach you for 1 hour on Tuesdays and Thursdays, and then a student who's been very successful in this course will teach you the same subjects, but from a different viewpoint. And this has been very effective way to improve your letter grade for classes that you enroll in. On average, I mean, this is what the data says, on average, those who attend learning, SI instruction, average about one letter grade higher than those who don't. Now, that's an average number. It's not every single person gets a whole letter grade higher, but the average is about one letter grade higher if you attend SI instructions. So I wrote notes on this. Today at 5 p.m. And I'll add also and Thursdays. A student, his first name is Johnson. We'll conduct an SI teaching session at Zoom number 886-115-8113-4. And it's supposed to be more informal than a real lecture that I do. You can meet and discuss with each other things I've talked about or things that he will present to you that he did when he was a student of assembly. Okay. So I'll leave it this way. If all this assembly stuff makes perfectly clear sense to you, why don't you skip it? If it's kind of foggy, you better be there because it gets foggier from here on out. Then you actually need this. Write down that number. I'm pretty sure it's going to remain all semester, that number. Every Tuesday, every Thursday at 5 o'clock. Go see what Johnson's doing. And he studied from me a long time ago, by the way. So you can ask him, how do you get an A out of holiday? And he'll really know. Okay, what's our next announcement? I'm very much in favor of SI learning. It reinforces what I leave kind of vague in class. Okay. Another announcement. Community learning. This is where our society changes. Community learning. When I was a student, mostly we were all isolated individuals. You went to class, you took your own notes, you went out on the grass or found a bench, you studied your own notes, you studied in the library, you came back, took a test, and repeated this repeatedly. But that's not the style anymore. In the last 5 or 8 years, the community style of helping each other is commonplace, and I'm all for it. So if you haven't been in the computer science Discord, it's time to go make yourself known. And did I write down the Discord link? Oh, I don't have it here. Okay, I'll get it by the end of the hour and put it on the page here. You should go there. There will be your peers who will solve almost any problem. If you have issues with installing WSL, activating it, someone there has already explained it for you. If you have trouble getting assignment number 1 working, someone there has been through it. They'll explain it. This is community learning or peer-to-peer teaching. I'm all in favor of it. Unfortunately, I thought I had it in my notes on the side of me, but I don't have the number yet. The URL. We'll make sure it pops up before we're done. If someone has it, you put in the What was it? So, okay. Yeah. All right. Oh, and by the way, you can't, when you can't reach me or you can't reach, Nicholas, my backup, then you can get answers here all through 24 hours a day. That's really good place to find out stuff that you need to know. Okay, so I asked in the chat messages, had we done 3-number input? And there was one answer that said no. So I'm going to approach that. You needed a 3-number input. You need it in assignment 1. Assignment 2 is already posted because you're all chugging ahead on this stuff, getting prepared for the big midterm. And let's enable some recordings. Okay. So how about I'm doing them as fast as I can. I'm doing them right now. Okay. Let's see. I'm clicking on a name and then it pops up a menu and then I choose allow record. Okay, he's recording. Did I get this one? And then allow record. And another one. And then I did that one. Let's see. So Ricardo, you asked for it, and then I'll make sure it works. And who else? Yosef, let's see if I did that. I can't find your name. It's supposed to be alphabetical, but here it is out of alphabetical order. And who else? William, did I give you permission? I think I did. Yeah, it's already there. Okay. And anybody else? Okay, put your name there so I just saved Omid. Maybe he wanted it. I don't know. He's recording. Email that we're coming back. Oh, it just I haven't been watching in the last couple hours. Hey, that adds new light to it. Class, you gotta come back for GE classes, and some faculty in the computer science department are demanding they want a crowd of students in their classroom. That's okay. In the classroom, your professor will do what he wants to do. That's academic freedom, they call it. In here, I'm not playing that game. I don't want the virus game played. So you have to do what you have to do in those other classes. Do your best to sit separated by 6 feet, and you survive. Okay, thanks for the updates that the emails come out. Okay, so I think we're up to date. Any more recordings, anybody? Okay, no messages. So let's try. Your homework asks for, okay. So when we end, remember, don't forget, 5 p.m., you just hang around for an hour break time. 5 p.m., you have a real sharp guy going to teach you at SI. We call it just SI. There's that big long number. It's a great experience. Yeah, I know Johnson. He was a great guy a couple of years ago when I had him in class. Okay, so it says something like there's a message. Please enter 2 sides of a triangle and the included angle. there's a prompt message for the user, and then the user is supposed to put in something like 12.6 and hit a couple spaces, space over, and then 18.9 and space over, and 36.85. And that represents, and press enter. And that represents side 1 and side 2 and angle in degrees, EEG. Okay, so we want to learn how to do that operation right there. Okay, we'll go to the next page. Start it clean. Okay, so assembly programming is already like reading hieroglyphics. So you try to put some organization to it so it looks nice. And a block structuring is a good thing to do. That means you group a section of instructions together to form a block of code and give that block a short title. Like my title will be input 2 sides and an angle into XMM 13, XMM 14, XMM 15 respectively. The title's too long, but we'll live with it this time. Okay, so that's a header to a block of assembly code that's going to do exactly this job. All right, well, up in the, before we can actually create that block, up in the segment data, we need a official formal description of 3 that specifies 3 numbers. Okay, so you make up a name, form 3, DB, quotes, percent LF, percent LF, percent LF, end of quotes, comma, and I can't squeeze it in, but there's a 0 on the end. So you're saying, well, LF is the designation for a double. LF with a percent means 64-bit. Float number, which we normally call a double. And therefore, percent F is a 32-bit float number. And percent LD is a 64-bit integer, which we normally call a long, and percent D is a 32-bit integer, which we normally call int, and percent S is a array of char. And arrays have different lengths, so we can't specify the number of bits anything on that one. Okay, so I put this in red because this is not in our section that we're working on. This is up above, high up in the software, high up in the program. And I'll add one last thing as we learn this. There are many others of these, 15 of some number like 15 more, but they're rather rare. And so I'll say, and there are others of these specifiers, they're called, and others. You won't need them. They're kind of rare. If you wanted your output to be in floating in, what is it, scientific form, there's a specifier that I've seen that will let you say, my output is 375,852 times 10 to the 7 or something. How do they actually do that? That's 37852. I think it's not E. I don't remember. See, it's so rare. I don't remember how they do it. But there's a specifier that could format your data to be in exponential form. We won't use it in this semester, but if you wanted to look it up sometime, it's an easy web search. Now let's go on where we continue. We're making in black ink, we're making a block that's going to go in segment text. Okay. So after that black ink, we start out by doing a setup for the built-in library function scanf. Okay, so how do we do this? Let's do the whole thing. Move RAX3. The 3 stands for the 3 numbers that we have, that we plan to have.
Professor, this is in segment text, right?
Yes, that's right. It's a continuation of that. That's a big comment back there. But now we're doing actual code, and it's no spacing in between, no blank lines. It's just all continuous. Segment text. And then we're doing this setup, and we do RDI gets, what the name did I give it in red ink? Form 3. Looks like that. Yeah, I hope that's in the center. Okay, and then we need, scanf wants to know where do you want scanf to put the incoming numbers? There's 3 of them. Okay, and you can go to the lab sessions and to the SI meetings and the Discord, and you'll get different answers. My answer is use the system stack. They'll tell you how to set up an array inside of the BSS segment and save it over there. Those are all valid, but here's my style. We're going to make space on the system stack for 3 quad words. Okay, so here it comes. Push, quad word. And the push operation needs an operand, but we just make up a garbage one. 99. Push, quad word, -700 is garbage. It doesn't mean anything. It just the push needs something to push on. 6,805. There you go. Okay. So we've created 3 quad words on the top of the stack, and we're going to tell scanf put the 3 numbers on those 3 quad words. Yeah, you got it. Okay. So how are we going to do that? We're going to say, make a copy of the top of stack. Okay, so.
Oh, and real quick question, Professor. I had one guy ask a question of what does move RAX3 do later on in the code? Because I know like
It tells
X
you,
comma 1, what?
it tells you there are 3 numbers involved.
I see. Okay, I will
Okay.
tell him that.
Okay. Yeah, we're working on 3 numbers. If we're inputting a single number, that would be a RAX comma 1. And scanf uses that for purposes of its own. I don't know what the purpose is, but that's what scanf wants to see. Okay, so let me put, do I have a blue ink or something? Blue ink says this one too. This one, this one. Okay. Those are of importance to ScanF. ScanF, I keep saying that word, is in the public library. It's when you link your program, we don't see it happen, but the functions from public libraries are then brought into the executable code at that time. So here it comes. It's call scanf. Okay. So scanf, what I was just saying one sentence earlier, is a public function. It's written by somebody dozens of years ago, and it's stayed ever since. It probably dates back to the beginning of C language. I don't know how long it went back. Okay, so scanf now looks at this one that I'm pointing to, RSI and RDI, and determines that there's 3 float numbers, quad word size, as a quad word size because of the LF. And the location to place them is on the top of the stack. And so it's going to wipe out these 3 junk numbers. Those will be overwritten by numbers coming in from the keyboard. Let's squeeze a picture in on the side. Okay. Okay, so RSP. And that's your stack. And here on the top is, there's important information there. Placed earlier, not by yourself perhaps, but it's still important information. 84.92, negative 6.99, 1000.0. Okay, we don't want to damage that data. So there are 3 pushes, and that created 3 quad words. Yeah, and the 99 went here. Remember, I called it the junk data because you could actually put almost anything there. And now RSP is here in the corner. Does that show up in the middle? Okay. And now scanf is called, I missed one step here. This one is a copy operation. This one is copied into that one. So we have right here RSI, 2 pointers to the same quad word, to put it simply. They both point at this junk 6850. All right, so then scanf says, okay, I'm expecting 3 numbers from the keyboard, and it's going to put those 3 numbers in the red quad words. How can I? I'm trying to find a color though. Okay, so let's say the first number you entered. Yeah, I actually had an example back here. Yeah, like that. See, the first number is 12.6. So 12.6 enters here. The next one is 18.9. And the last one is 36.85. Okay, and that's what scanf does. But that's not our goal. The block said input three sides in an angle and put them into XM13, XM14, and XM15 respectively. We haven't finished that job. Okay, so let's continue our block, and we get to where. Okay, right here. That's the first one entered. That's the side 1. what did I say? Side one is XMM 13. So MOV SD XMM 13, comma, that should be on one line, but I don't have the space for it. RSP. Got it? That's one state, one instruction. Okay, so this number 12.6 is now in the register RMM 13. We should take that off the stack. And now, after taking it off the stack, I have to cross it all. RSP is not here, it's back here. Okay, so now let's get the 18.9 in its proper place. XMM 14, comma, RSP. Isn't that interesting? It looks like that, but it's a different number. This is RSP at the time slice when it was back here, but now we're taking RSP, which is 18.9, when RSP is right here where my pencil is, where I put the dot. Now we're done with 18.9, so let's take it off the stack and throw it away. And then RSP is here at 36.85. That works here. And then we move SD, XMM. This is the angle, 36 degrees, 0.85, XMM. That's supposed to be a 15, comma, RSP. Okay, we're done with it. 36.85 is in XMM 15. It's time to pop that one and we restore it right here. And look, that's neat. We put the stack back into its original configuration. When we started, and do I have something? When we started, that was the stack right there. And then we do our block of work. And during the block of work, it went to here, here, and here. And then we got the numbers out of it and put them in the XMM registers. And then we put it back. And when we're all done with this block, the stack has resumed its original configuration. That's actually a good thing. That stacks return to where they were at the when you started out with them. If you leave dangling stuff on the stack, it won't, your function won't return, by the way. It hangs at the return statement. Very common problem. Let's see, I should be watching. Any questions, class? Everybody. Nobody had a question. You all absorb that? You know what? You guys don't even need the SI sessions. You're already A students. It's pretty cool. I couldn't absorb that on my first day. Okay. Now, if it doesn't make sense, you want a review of it, then you get a review at 5 o'clock. Let's see. Oh, then we draw a picture of the XMMs. Everybody knows what XMM does. Old time programmers, new time programmers, all same. There's a visible line down the middle, by the way. And these are labeled always going up. XMM 0, XMM 1. And the last one is XMM 15. Okay, so, we ought to put the blue ink in place. Where's the blue ink? Are we okay on the time? We've got 20 minutes left. Okay, blue ink is, I lost my place, 12.6. And then it was 18 point, I think it's a 4. Can't read it. 18. What was the number? 18.9. And the last one was a bunch of angles. That was 36.85. Okay, and that's our configuration at the end of this block. As far as this goes, this whole segment is called SSE. Okay, this whole group of registers and their instructions that go with them are entitled SSE. The individual registers are XMMs, and we have our data, 3 numbers, XMM 14, XMM 13. And we did it, see, we call it 3 at one time because there was only one call to scanf. It did 3 of them for us in one call. More tedious, you could break that up into 3 calls to scanf and get those numbers one by one. But this is the way your handout describes the homework. Okay. So let's see. Let me view the questions. Charlie Taylor, yes. Those are just placeholders. Charles, I got you. And the move XMM blog is in the segment text. Greg, that's exactly right. Okay. So that's the end of the first one. Okay, so what do you think, everybody, you think you can finish this homework off by Friday? I'll give you some more hints on it. What do you have to do? You have to find, is it the area of a triangle, every area of a right triangle? Oh,
Area and perimeter.
okay. Let's see. So we want the area and what's the
Given
formula? 1/2 of base times the height. Okay.
well, it was like the thing is
Or actually,
length side 1, length side 2, and degree of angle between them has real float numbers. So
oh, I see. That's not a right triangle. Okay. I should probably read the thing and make sure it's on another screen. You entered these area of triangle. Okay. Well, okay. It's the base times height times the sine of the angle between them. I'm pretty sure. Why don't you all, or is it the cosine? You look in Wikipedia, find out what the area is when you know the angle between the 2 sides. I have a feeling it's the base of the triangle time base length times height. Oh no, it's side. I'm sorry, side 1 times side 2 times cosine of angle. There's alpha. Okay, so let's solve this problem so that you can knock this program done by the weekend. How are we gonna find that, solve that equation? To do that, I'd make a map first. Let's designate what we're using. XMM 15 is side 1. XMM 14 is side 2. XMM 13 equals angle. XMM 12 is cosine of angle. And XMM, we need to make I'm not sure we need to make a backup of one of these, but I'll reserve that for it. Okay, you already saw how we get these. Okay, so let's compute the cosine of the value stored in XMM13. Let's okay, let's go move. That's a float number, RAX1, and move. And I should make a block here. This is compute cosine of angle XMM13. Okay, so we'll continue. And then let's see, we're going to move XMM0, XMM13. And one more, and then I'll go back and we'll walk through it. Is that sufficient? I think so. Just, that's a call. CALL cosine. And then, man, I'm missing stuff. That's an SD, move SD, XMM12, XMM0. There we go. I think that completes the block. Yeah. So let's back through it. The first one is commonplace. That's you'll be so familiar with it. It just sounds common. It says we're working with one number. Well, okay. One number is the angle. Okay. This one says copy the angle into XMM0. You can see the copy operation goes from right to left. Cosine looks inside of XMM0 to get its angle. Wow, you know what? There may be a problem. I think those cosines looking for radians. We may not have radians. But let's explain the structure here first. And then when cosine finishes, it puts the answer in the same place where it got its angle. So we want to put the answer in here, and then that satisfies that this one. Everyone follow that? Let me see if there's a question on this thing, guy.
So Professor, when you define XMM15 equals side 1, this is all in the segment text area?
No, yes, but these are comments.
Oh, they're comments.
These are for me to remember.
Okay.
And all this is happening in XMM. Let me try that. All this is happening in segment text. So what I did earlier was to input 3 numbers. That was in segment text, all this. And now we're trying to use the angle that was inputted and compute the cosine of that angle. And here's how it works in principle, but I'm worried that cosine only accepts radians, not angles. That's a new, I hadn't planned on this problem. This is correct. This block is correct, except the angle comes in degrees. Okay, so what do we have to do? We have to multiply the angle by pi and divide by 180. And then, okay, this is a new problem. What can we do? I'll give you an answer. I'm trying to think of an easy one. Okay. Okay, this is gonna have a new block here. How to convert degree to radians. Okay, in ordinary math, it would be radians equals the degree times pi over 180. I'm pretty sure that's, yeah, I'm pretty sure that's it. Okay, so we have to do that in assembly. So we know what degrees are. That's XMM 13. And we'll make a new location for this one. This will be angle in radians. This is angle degree. Okay. Yeah, I need to help you with this. This is not as clean as the other things. Okay, give me a minute here. I need to look up what is pi in we need pi in hex values. I'm looking, class, to find that constant. That's the real problem. Stay with me. I got it someplace, but
You should also take news of this to the other class because they have the same homework.
yeah, you're going to be helping them, I suppose. Or I better warn. See, okay, here's our issue is I need the number pi, but the assembler will not accept float numbers in decimal. You just can't input 3.1416
Uh,
and it won't accept that. I need it already in hex and I gotta look this up somewhere. How can I?
darn.
Let me try here. I gotta plug in my. See if I can do this. I'm trying. Oh, we can't. How can I do this? Okay. Okay.
Oh, boy.
Did I find this? What happened? Okay.
I found an output.
I'm teaching.
Again, I've been, I used Wolf,
Numbers.
search to find Wolfram Alpha and then just convert pi to base 16, and that's the
times this. Oops.
I originally found a formula to convert, or
This,
not convert, computing the hex value of pi, and I didn't think that's what you wanted to use.
I just want this hex value itself. I don't want.
Yeah, I put it in chat. 3.243 F6A 8885A3 and it continues, but
Oh,
you can cut that off at whatever point you want.
no, that doesn't. No, the machine would, the assembler would treat that as a decimal number. It has to start with 0x.
Uh,
It's a hard one to find. I'm still trying to locate it in my. Okay, so
pi.
okay, here we go. 1, 2, 3, 4. Where's my? Where's the black thing? Okay, so. And 921 FB. Five, 4, 4, 4. 2D18. That's a 1, 8. Okay. I guess I'll share this with you. So move to 2 and close this guy. Did I lose it? Let's find out. Okay. Move to 3. Okay, so to share this, how do we do this? Share screen. Here is part of it. You're looking at some numbers. The one of interest is here. Okay, that's pi in is a quad word. It's 16 hex digits. And see, just for learning, here's pi in decimal. But when you look at it in computer coding, hex bases, it looks like that. This is pi in something larger than 64 bits. That's actually 80-bit pi. So what I'm going to do, I'm copied this number and it's on the screen in front of us here. Okay, so I'll show you how to. Here's what we're going to solve. We have a number in XMM13. We're calling angle is in XMM13. And I want to multiply that angle by pi and then divide by 180. Okay. So we still have to get 180. Let's, okay. Let's do this one.
It's 3 o'clock now, but if you want to continue on, go by all means, go ahead because figuring out the.
This is going to be 15 minutes worth of stuff. Maybe we should start at the beginning of next hour.
Well,
Okay, so let's lay the
Everybody's-
groundwork. I'll lay the groundwork for it. We got this angle and we're gonna multiply by pi and then divide by 180. So here is, this is scratch paper now, class. Well, I'm gonna move SD. No, it's gonna take a lot of work. Okay, no, there's no answer. There's no short way. Okay. I got to get hold of these two constants. Here it is. And we're gonna RAX comma 0x 4000921 FB 54442D18. And we're gonna push it. Push RAX. Copy it. Move SD. What's the register we haven't used? 10. Move XMM 10, comma, top of stack. And then pop RAX. Okay, so this block places pi in XMM10. Now XMM10 equals pi. Yeah. Now we need 180 as a float number. We'll put it in XMM9. Okay, you ready? So the header on this block is put pi into XMM10. Okay, draw a line here. The next one is put 180.0 into XMM9. With me? Okay. What we do is put a copy of 180 integer. 180. I misprint here. Move RAX 180. Okay. Then I'm going to call upon the convert function to convert it from integer encoding to floating point encoding. Okay, so CVT SI to SD XMM. We're going to put it into 9 RAX. I think we're done. Okay. Now what do we have? To summarize it, XMM, I lost the number on it. The angle is in 13, XMM 13 equals angle in degrees. XMM 10 is pi. XMM 9 is 180.0, float number, not an integer. Okay. And now we're supposed to, let's get the job done. The destination is to put the angle as radians into, I think, 12. Where do we want? I did have her say. We'll make it that way. I can't see that 12 is used for anything else. XMM 12 will become the angle in radians. We're going to finish in 2 minutes, so stay with it. We got all the hard work done. So here it comes. Let's take the angle in degrees and put a copy in 12. Move SD XMM 12 XMM 13. Now the angle in degrees is in 12. Let's multiply by pi. MULSD XMM 12 comma XMM, where's pi? 10. Okay. So the radians has been, the degrees has been multiplied by pi, and the answer is sitting in 12. Now let's divide by 180. XMM 12, comma, where's 180? 180 is in 9. XMM 9. This is done. The end result is now, that's comment now. Now XMM 12 equals the angle in radians. Okay. And everybody, that's real nitty gritty assembly. We're gonna, I promise you I'll do it again at the start of next class meeting on Thursday. How to convert an angle from degrees into radians. The angle starts in 13. So I'm doing summaries here. Convert angle.
Just to say it, there appears, or I've been looking for how to calculate the sine of a degree, how to calculate the sine of an angle in assembly, and there's at least one example where there's an F sine function. I don't know that. I don't know that.
Sine function or cosine or tangent, you'll call them in the same way. You do the setup and then say call followed by the name of the function. Do angle in where was our destination? XMM 12.
These blocks before or after the compute cosine block.
Okay, so this operation up here was an angle, made a copy of the angle here. We multiply by pi, and the answer stays there. And then you divide by 180, and the answer stays here. And when you're done, the answer here is that same angle, but now measured in radians. The angle started here in degrees. So this is the radian one. This is the degree. Okay. If you're recording this, you got to go wrap your head around it, how we got there. There's a block of code to make that happen. In ordinary C++ programming, it would say you would declare double angle degree, double angle radian, and you'd say angle radian equals angle degree times 3.1416 divided by 1800. Okay, it's one statement. But when you break that one statement into its atomic parts, there's no subdivision further possible. It's this set of statements. That's what your compiler will create is executable code that carries out these steps. And we in assembly do that for the compiler. We break it down into its basic atomic parts, its atomic steps. There is no further software to act on this. This is moved in electricity in hardware. Copies these 64 bits into there. It moves this into the ALU unit, arithmetic logic unit, and this one too, and does a multiplication in electricity, not in other software. This one moves those two into the arithmetic logic unit, does a calculation in electricity, and leaves the answer here. And when we're done, that's the radians of what started out as degrees back here. Okay. So in high-level programming, that's one line, but that's so complex that the compiler has to generate executable code, and an assembly sort of matches one instruction to one executable statement in the compiled code. Okay, class, we're running out of time. What you do is, if you didn't get the conversion of angle, you carry through with inputting 3 numbers. You can program that yourself and then pause. You don't have to build the whole thing. You build enough so you can input 3 numbers. Where did we do them? We did them way back here. Remember all that? Input those 3 numbers and confirm that that much works. And I'll resume on Thursday by the next step, which is computing the area. Compute the
And I'm here to
area.
answer questions.
Okay. Was there a question?
No, I'm just, somebody saying, are these blocks before or after the compute cosine block? And
Oh, before. See, we need cosine wants radians. So we have to do this work of converting degrees to radians first, and then call the compute cosine block. They did, the people who long ago made these library functions, math functions, tangent and cotangent and cosine and sine, they assumed all angles would be radians. Therefore, it's up to us to convert our numbers to radians. Okay, so let me see. That last question was, first block is input 3 numbers. Second is, one of those 3 numbers is an angle. Convert angle number to radian. And the third one is find area, which includes calling on, you guys, you got to look it up. When you find the area of an angle of a triangle where you know 2 sides and the angle in the middle, do you call cosine or do you call sine? But make sure you're calling the right one. You call cosine and pass to it the radian number. Passing to cosine the radian number. Okay, and then the next block would be display your results. Show area as a number. number of square units. Okay, so you see the assembly is falling into place slowly by blocks. This is a task to be performed, a task for the program. This is a task to be performed. This is a task. This is a task. The next will be to compute perimeter. Compute perimeter. And near the end will be a task, I call it a block, a code that displays the perimeter. Displays perimeter. Okay. Okay, so don't get overwhelmed. You work on a little, one block at a time. Block that out and you work on this piece first. So I mostly gave it to you earlier in this hour. Go make that work, make it air free, and then you add this block after it, the convert to angle. And if you got that recorded, it's in here, but it's, although I admit it's kind of messy. I didn't come prepared for that one. I really didn't think ahead. I didn't know that was going to come up, but it did. Okay. I'm going to pause here. I went 20 minutes over time. Nick's going to answer your good questions. And we're glad that he's taking charge. I'll close this guy here.
Yep.
And I'm going to, where's the, can't find it. You're probably at the top. Yeah, there. Make post. Yes. Yeah, close this one. This one. Hey.
Mm. Let's see. I can't believe nobody has ever posted anything about the GDB debugger. Assumes it's installed. Jiqiang Liu, your mic is on. Right now it is just lab, yes. If you got questions, that's what I'm here for. For what it's worth, I was also looking up how to calculate sine in assembly while the lecture was happening. Craig saying, so it's not cos, right, for area calculation? I could even give you like. Yeah. Excuse me while I turn off notification sounds for emails.